Have you guys seen secant, cosecant, and cotangent before? I don't think they have to be introduced before now. So secant, cosecant, and cotangent are known as the reciprocal functions. So secant is going to be abbreviated SEC. So you'll have secant x. That is going to equal 1 over cosine. Cosecant is 1 over sine, and cotangent is 1 over tangent. Here. So whenever I am teaching kids to memorize these different things, I always tell them for the reciprocal functions to remember that you must have a co in every pair. Tangent and cotangent go together like they sound like they do. Sine and cosine don't go together. But secant has to go with cosine, because if it went with sine, then you would not have a co. Cosecant has to go with sine, because if it went with cosine, you'd have 2 cos, and you cannot have 2 cos. You can have to have 1 co and one that doesn't have a co with it. So secant is 1 over cosine, cosecant is 1 over sine. So let's look quickly at the graphs. Secant and cosecant have graphs that look really similar, much like sine and cosine have graphs that look really similar to each other. Because secant is 1 over cosine of x, in here, Mr. Passwater has graphed the cosine function, right? That dotted line is not part of our secant graph, it is our cosine function. Notice, what happens every time cosine equals 0? What have we got at every place that cosine equals 0? Vertical asymptotes, right? Because we've got 1 divided by 0, which is undefined, right? Notice something similar over here. We got 1 over sine of x for our cosecant function. So Mr. Passwater has graphed sine right here for me. And notice, every time sine equals 0, we've got a vertical asymptote. So a lot of times if I'm asked about questions about these, I actually think about the sine or the cosine graph a lot more than I think about the actual secant or cosecant graph, because they're a little harder to think about. So like the vertical asymptotes in this case are going to be, I'm going to write it 2 different ways. So if they will allow you, you could just like list some of them: negative 3 pi over 2, negative pi over 2, pi over 2, 3 pi over 2, right? And if I was having to do this without looking at the graph, I would be thinking, where is cosine 0, right? Whenever cosine is 0, it's at pi over 2, 3 pi over 2, and so on. Then I'm going to have vertical asymptotes. How could I write this with pi's and k's? How far apart are each one of my vertical asymptotes here? Not 2 pi. Just pi here. Now the period of the graph is still 2 pi. But if I'm just wanting to give the equations for the vertical asymptotes, I'm going from pi over 2 to 3 pi over 2. And then 3 pi over 2 to 5 pi over 2. That's just the distance of pi. So what I can do here is I can do like we did for our vertical asymptotes on some of our other things. I'm going to just pick one. Usually I pick the first positive one, which is pi over 2. And I can add pi times k. I have to say that k is an integer. If you see like a multiple choice question, I think you're more likely to see that than to see it listed out. Okay, so if we look at the vertical asymptotes for cosecant, and I want to do those the same way, what could I do for that? I could pick the first positive one, but I do have a vertical asymptote at 0 here. That would be even better, right? I could do 0 plus These also are just spaced out by a distance of pi. So I do pi times k, where k is an integer. Now what they'll probably do for that is they probably will not put that 0 there. They'll probably just say pi times k, because 0 plus pi times k is just pi times k. 0 could be like your first vertical asymptote. You also could use pi or 2 pi or 3 pi or 4 pi. Like you would technically be correct to use any of those, but the most standard one, like if it's a multiple choice question you're probably going to see, is that they'll use that 0 right there. Okay? The range for secant and cosecant is going to sort of be the opposite of your range for sine and cosine. For sine and cosine, we've got -1 to +1, right? But whenever we do these reciprocal functions, they've got this big space from -1 to +1. So in this graph, you would have -infinity up to -1. You can use a bracket there because it does actually equal -1. And then you would have 1 to infinity. So these graphs have like a gap in the middle. That gap is where your sine function would fit right in there perfectly if you use the corresponding sine function. Okay, questions so far? All right, cotangent is going to look like this. Cotangent is 1 over tangent of x. We also learned that tangent of x equals sine x over cosine x, right? We learned that earlier when we were talking about tangent. So if y equals cotangent x equals 1 over tangent x, I could replace tangent x with sine x over cosine x, correct? Like they're equal to each other, tangent x equals sine x over cosine x. And then dividing fractions is easy as pie. I could flip the second and multiply. So what we end up with here is that cotangent x also equals cosine x over sine x. So cotangent x is going to have vertical asymptotes anytime sine x equals 0. So if you think about where sine x equals 0, those vertical asymptotes are going to look like the same thing that they looked like here. With cosecant, because it's 1 over sine as well. So it's going to have vertical asymptotes anytime sine equals 0. So you're going to have x equals pi k. K is an integer for this. And your range is going to be -infinity to infinity. Notice that your tangent function is decreasing in all of your little increments, whereas, your cotangent function is decreasing, whereas all of your tangent functions were increasing. So they look like they've been flipped there. Okay, so whenever I do a problem like this, f of x equals 3 secant of 2x, and we want to know which of the following is a vertical asymptote of f. I always think of this as one, well, I guess this would be 3 times 1 over cosine of 2x. So I want to think about that cosine graph equaling 0. I want to think about where does cosine of 2x equal 0. for this. For just regular cosine. For regular cosine, where does cosine equal 0? In that unit circle. Okay, pi over 2, 3 pi over 2, right? So for regular cosine, it would be pi over 2 and 3 pi over 2. But this function has a 2x and not just an x, so I'm going to say 2x equals pi over 2 and 2x equals 3 pi over 2. So that means I'd have to divide by 2 here. I'm going to multiply by 1/2 because it's easier over here. And I would get pi over 4, which is this answer choice. I don't actually end up having to do this one because that would give me 3 pi over 4. It's not an answer choice. They only gave me one of the answer choices there. They would not in the multiple choice question right there. Unless they were saying, like, unless answer choice C was pi over 4 and 3 pi over 4, they wouldn't give you both of those as answer choices. Okay. Let's think of example 2. I've got cosecant of pi x. Vertical asymptotes, it doesn't matter if I shift them up or down or stretch them out. That does not affect my vertical asymptotes. It's only horizontal shifts or stretches or shrinks that are going to affect this. So I'm going to think about this like 4 minus 2 times 1 over sine of pi times x. And I need to ask myself, where does sine of pi x equal 0? Thinking about pi x is too hard. Just think about sine. Where does sine equal 0? Okay, over here at 0, also over here at pi. So pi times x could equal 0. Pi times x could equal pi. It's possible there's something else, but I think at least one of these will give us an answer. Yeah, you could do 2 pi. You could do pi times x equals 2 pi as well, because that 0 could also be 2 pi. So if you don't get one that works, you could consider it. Right here, you're going to divide by pi, and you get x equals 0. Not an answer choice. It is a vertical asymptote, but it's not an answer choice. Right here, you're going to divide by pi, and pi divided by pi is 1, so D is your answer here. You also could do 2 pi, x equals 2 would be an answer, but it's not an answer choice, so we're going with D there. Okay, looking at example 3, it's going to ask us about the range for this function. So the range for this function is going to be, we're going to really like think about how the graph works for this. So whenever we're looking at secant or cosecant, the sine function that corresponds with it or the cosine function that corresponds with it fits in between the graph, right? So like right here, our range for both of these was from negative infinity to negative 1 and 1 to infinity. If I were to think about the sine function that goes with this graph, when I change the amplitude of that graph, that makes that sine function taller, right? That means that your cosecant graph has a bigger gap in the middle so that that graph can fit. So whatever the amplitude of this graph, it's not really called the amplitude whenever we're talking about cosecant, but you can think about the amplitude of the sine function that corresponds to it. The amplitude would be 3, so C is going to be your answer for that. Does that make sense? That sine function that goes with it's got to fit in between, which means a sine function with an amplitude of 3 would go up to 3 and down to negative 3. And so that part's your gap in the middle, and it's going to be the rest of the values. Okay, Let's skip 4. It's more of the same. Let's look at 5 so we can get one of these done real quick. We've got 4 cosecant x plus 3, and we're looking for intersection, so it's going to equal 11. Okay, so solving these is much like what we've already been doing. You're going to subtract 3. We got 4 cosecant x equals 8 there. We're going to divide by 4. And so cosecant of x equals 2. Cosecant is not on our unit circle, but the reciprocal function for it is, right? So cosecant of x equals 1 over sine x. So if cosecant equals 2 over 1, sine of x equals 1/2. So you can just flip it to a sine or a cosine or a tangent function, and then you can think about it on the unit circle. So whatever you have here, a lot of times it's a whole number. You just put it over 1 and you flip that. We're just going to give the values where sine of x equals 1/2. And on the unit circle, sine is your y-coordinate equals 1/2 at pi over 6 and 5 pi over 6 for your answers for that. All right, so let's do on that worksheet, I want you guys to do 1, 4, 6, try 7. It's a little bit, it's got a little extra stretch. And then let's do 8 and 9. So not quite everything. 1, 4, 6, 7, 8, and 9.